In this video, we will discuss about the deconvolution of a signal and systems. So we will start from an example. For if a signal xn is equals to 1 comma 1 comma minus 1 is convoluted with an unknown signal h of n, and the convolution result is noted as 1 3 1 minus 2. And the question is that you need to find what was h of n. We will consider a linear case, and we know that the total number of sample in the resultant convoluted signal is calculated using this formula m plus n minus 1. And the resultant signal is given, where we can see that the total number of sample in the resultant signal is 4. So you can insert m plus n minus 1 is equals to 4, where the value of n, that is the number of sample in h of n, that is unknown, but the value of m, that is the number of sample in xn, that is known, which is equals to 1, 2 and 3. So the value of m is 3. So if you insert the value of m 3 in this formula, then you can easily calculate what is the value of n, because m is 3 minus 1. So 3 minus 1, the answer is 2. So n plus 2 is equals to 4. So n is equals to 2. So you just assume that suppose the h of n has a sample a comma b. You can consider any value like x and y or whatever, but I said we consider the unknown samples, that is a comma b. So we again draw the table, and we know that in the first row we just insert the xn values, which is 1, 1 and minus 1. And on the column we draw the number of samples in h of n, that is a, b. So and you multiply that first sample with this first row, so that the answer will be a minus a, and then the second sample with this row, then the answer will be b and then minus a. Then draw diagonal lines here, and then you can see what is the value of y of n. So y of n, the first sample is a, then the second, in between the second sample you can say a plus b, then the third sample you can see minus a plus b, and then the fourth sample is minus b. And then you can compare. So you can compare this y of n with this sample. So then you can say, okay, a is equals to 1 and then b is equals to 2, because you can see the first sample a, you can see the first sample is a. If you compare this y of n with this resultant signal, here the first sample is 1, but here is the first sample a. So you can say that the value of a is equals to 1. The last sample here is minus b, but last sample here is minus 2. So if you compare minus b with minus 2, the value of b will be equals to 2. So if you consider these values, a is equals to 1, b is equals to, and you insert these value in this y of n, then you can end up with the same result. So that is 1, 3, 1 and then minus 2. So in this way you can say that the value of a is equals to 1 and the value of b is equals to 2. And then you can draw these values here instead of a and b and write a new table here, and then you can see either the result is correct or wrong. So first you write the value of a is 1. So if you multiply this one with this first row, the answer is 1, 1 and then minus 1. The value of b is 2. If you multiply this 2 with this row, then the answer is 2, 2 and then minus 2. And then you can end up with this result. Then first sample is here, then the second sample will be the sum of these two samples, 1 plus 2, then the third sample will be the sum of these two, so that is minus 1 plus 2, and the fourth sample is as it is, that is minus 2. And then you can see that the result y of n is equals to 1, 3, 1 and minus 2. That was the resultant signal. Then you can easily say, okay, the value of h of n is equals to 1 comma 2. The second method is the division method. We will see that using the division method, how can we calculate the unknown value. So we have few steps in order to solve using the division method. The first step is that you need to represent the given signal with a polynomial. and the polynomial in such that you will write the degree of the polynomial in an ascending order. The second step is that you need to represent the resultant convoluted signal as a polynomial in the same way that the degree of the polynomials or the degree of the variable in the polynomial should be in the increasing order. The third step is that divide the resultant polynomial by the given signal polynomial, mean whatever the polynomial you will get from this step 2, you will divide that polynomial with the polynomial you will get from this step 1. So let's have an example where you can easily use the division method. So if x of n is equals to 1, 1, minus 1 and the resultant or the convoluted signal is 1, 3, 1, minus 2, where you need to calculate the value of h of n. If y of n is the resultant of the convolution of x of n with h of n. So similarly, as we know the division method, so we will perform those 3 steps that we have already seen in the last slide. X of n, so we draw the polynomial, so the first one is 1 is 1, then second is plus 1, so the plus x, the third one is minus 1, so minus x square. So you are increasing the degree of the polynomial, so 1 and then 2. The third one is the y of n, so where 1, so 1 plus 3x plus 1x square minus 2x cube. Okay, so that is the polynomial of the resultant signal. So you will divide this polynomial with that polynomial here. So like 1 plus 3x plus x square minus 2x cube is divided by 1 plus x minus x square. So if you see that the first component of that polynomial is 1 and the first component of this polynomial is also 1, so you will just have a quotient 1. And then the answer will be equals to 1 plus x minus x square, and then you can subtract, because when subtracting the sign will be changed, 1 will be cancelled with 1, and then plus 3x minus x, the answer is 2x. So plus x square minus x square, this will be cancelled as well. Plus x square and then plus x square, this will be 2x square, and then minus 2x cube as it is. So then you can see the first coefficient is 2x, and then you can see that the first coefficient is 2 and the variable is x, but here it is 1. So the quotient will be plus 2x. So multiplied that with this one, so the answer will be 2x plus 2x square minus 2x cube. And then you can see if you subtract that from this one, then the result will be 0. So you end up with a quotient 1 plus 2x here. So you can again have the polynomial of h of n, that is 1 plus 2x. So you can represent that polynomial in the form of samples. So 1 is 1 and then 2 is 2. So you can verify using the previous method as well. So you draw the table here 1, 1 and then minus 1, and you draw the sample of h of n, 1 and then 2, and then you multiply step by step, like 1 with this one, so and then 2 with that 1 with that row, and then you can see by drawing the diagonal lines what is the resultant signal. So the resultant signal you have already, so that is 1 and then 3 and then 1 and then minus 2, so the same resultant signal. So it means that you have done you have calculated the h of n, so that is 1, 2 using the division method.